if y equal to log of sin x. Next example, if y is equal to log of sin x, then value for d square y by dx square, then d square y by dx square equal to question mark. Okay, we have to give an options here. Number first option, minus cosec square x. Second option is minus cosec square x into cot x. Option C, sec square x, and option D is sec square x into tan x. Okay, this is very simple example. We have to find derivative for this equation 2 times. Now first we differentiate this equation with respect to x. Derivative of y is dy by dx equal to derivative of log of sin x. This is composite function. Derivative of log of sin x, suppose this sin x as f of x, that is we get log of f of x, and we know that derivative of log of f of x is 1 upon f of x into f dash of x. Therefore we can write here 1 upon sin x into derivative of sin x is cos x. Okay, that is we get here dy by dx is equal to cos x upon sin x, means cot x. Okay, now we have to find second derivative. Therefore differentiate this equation again with respect to x. Derivative of dy by dx, d square y by dx square is equal to derivative of cot x minus cosec square x minus cosec square x. Okay, therefore our correct answer is option number A. This is very simple example which is asked in competitive examination. Now we see next example here. Now we see examples on nth order derivative. Okay, we know that there are 3 steps for the finding the nth order derivative. First consider given equation, then find out first derivative, then find out second derivative, and also we find third derivative of the given function, and then consider or compare the powers of the terms, signs and functions, and considering third order derivative we can write the nth order derivative for the given function directly. Now we see examples here. Now first example for nth order derivative, if y equal to sin x, if y is equal to sin x is a simple function, then nth order derivative, then nth order derivative, that is dny by dx raised to n is equal to question mark. Okay, now we have to give an options here. Option number first, that is A, cos of n pi by 2 plus x. Option number B, sin of n pi by 2 plus x, sin of n pi upon 2 plus x. Option C, minus sin of n pi by 2 plus x minus sin of n pi by 2 plus x. And option D is minus cos of n pi by 2 plus x. Okay, now we have to find nth order derivative for the function y equal to sin x. Consider this function y equal to sin x, differentiate this with respect to x. Derivative of y dy by dx, derivative of sin x cos x. Okay, now we have to write this function cos x as in the form of sin x. Therefore we can write here dy by dx is equal to sin of pi by 2 plus x by allied angle formula. Sin of pi by 2 plus x means cos x. Sin of pi by 2 plus theta is equal to cos theta. Therefore, cos theta equal to sin of pi by 2 plus theta. Okay. Now differentiate this with respect to x. Derivative of dy by dx, d square y by dx square is equal to, we can write derivative for this, cos of pi by 2 plus x into derivative of pi by 2 plus x is 1. Okay. Now again we can write this function cos in the form of sine like this, d square y by dx square is equal to sine of pi by 2 plus pi by 2 plus x. Okay, by allied angle formula again, that is we get here d square y by dx square is equal to sine of, addition of these two terms is 2 pi by 2 plus x. Okay, now differentiate this again with respect to x. Differentiate with respect to x, that is third derivative of the function is d cube y by dx cube. Derivative of d square y by dx square, d cube y by dx cube is equal to, derivative of this term is cos of 2 pi by 2 plus x into derivative of 2 pi by 2 plus x is 1. Okay. Now again we can write this in the form of sine. Sine of pi by 2 plus 2 pi by 2 means pi plus x. Okay. Now taking addition here, pi by 2 plus pi means 3 pi by 2. That is, we can write here d cube y by dx cube is equal to sine of pi by 2 plus pi, 3 pi by 2 plus x. 3 pi by 2 plus x. Okay. Now here signs are positive for the all derivatives, first derivative, second derivative, third derivative, and here sign, here also in second order derivative sign. Okay. Angle is 2 pi by 2 plus x. When second order derivative, here angle is 2 pi by 2. When third order derivative, here angle is 3 pi by 2, and remaining terms are same, sin and x. Okay. Now continuing in this way, we can find the nth order derivative for this function, which is, we can write here dny by dx raised to n sin as it is. Instead of 3 pi by 2, we can write here n pi by 2 plus x as it is. Okay, that is our answer is sin of n pi by 2 plus x. Value for dny by dx raised to n is sin n pi by 2 plus x, which is in option number B. This is the correct answer. Okay, now we see here next example, the nth order derivative. Example, the nth order derivative of function 1 upon 3x minus 5 is, we have to find nth order derivative for the function 1 upon 3x minus 5. Now we have to give one options here. Option number first, a minus 1 raised to n minus 1 into n minus 1 factorial into 3 raised to n upon 3x minus 5 bracket raised to n minus 1. Okay. Option B, minus 1 raised to n into n factorial into 3 raised to n upon 3x minus 5 bracket raised to n plus 1, 3x minus 5 bracket raised to n plus 1. Option C, minus 1 raised to n into n factorial into 3 raised to n plus 1 upon 3x minus 5 bracket raised to n and option D, last option is minus 1 raised to, sorry, option D is none of them. None of them. Okay. We have to find correct answer here. Now consider this function as a y, that is we can write here y is equal to 1 upon 3x minus 5. We can write here 1 upon 3x minus 5 raised to 1, that is we can write here y is equal to 3x minus 5 bracket raised to minus 1. Okay, or we can use formula for derivative of 1 by x is equal to minus 1 upon x square. Now we can take derivative for this function. Differentiate with respect to x. First derivative, dy by dx is equal to minus 1 into 3x minus 5 bracket raised to minus 1 into derivative of 3x minus 5. Derivative of 3x is 3, derivative of minus 5 is 0. Therefore we can write here into 3. Okay, this is the first derivative. Now we can find second derivative here. Again differentiate this equation with respect to x. We can write derivative of dy by dx, d square y by dx square. This term and this 3 as it is, minus 1 into here minus 2. Derivative of 3x minus 5 bracket raised to minus 2 is minus 2 into 3x minus 5 bracket raised to minus 2 minus 1, that is minus 3 into derivative of 3x minus 5 is 3 into 3. This 3 as it is into derivative of 3x minus 5 is 3. Okay, that is we can write here d square y by dx square is equal to minus 1 into minus 2 into 3x minus 5 bracket raised to minus 3 into 3 raised to 2. Okay, now we have to find again third derivative, then we can conclude. Differentiate this with respect to x. Okay, derivative of d square y by dx square is d cube y by dx cube. D cube y by dx cube is equal to minus 1 into minus 2. Derivative of this term is minus 3 into 3x minus 5 bracket into minus 3 minus 1 minus 4 into 3 raised to 2 into derivative of 3x minus 5 is 3 into 3. Okay, now we can write here d cube y by dx cube. Now here minus into minus 3 times, third order derivative, therefore we can write here minus 1 raised to 3. Okay, observing the signs, minus sign at 3 times here, we can write here minus 1 raised to 3. Here 3 square means 3 into 3 into 3 times, therefore we can write here 3 into 3 into 1 into 2 into 3. This is the product of first 3 natural number. This can be written as in the form 3 factorial, and 3x minus 5 bracket raised to minus 4 can be written as 1 upon 3x minus 5 bracket raised to 4. Okay, when third order derivative, we write here minus 1 raised to 3, 3 raised to 3 into 3 factorial upon 3x minus 5 bracket raised to 4. Now considering this third order derivative, we can write here nth order derivative directly. dny by dx raised to n is equal to, when third order derivative minus 1 raised to 3, therefore we can write here when nth order derivative minus 1 raised to n. Okay, now when third order derivative here, we get 3 raised to 3. In nth order derivative we can write here 3 raised to n into, in third order derivative here we get 3 factorial, in nth order derivative we can write here n factorial. Instead of 3 we can write n upon, here in third order derivative 3x minus 5 bracket raised to 4, that is 3 plus 1. Therefore we can write here 3x minus 5 bracket raised to n plus 1. Okay, this is the nth order derivative for the given function, and this answer is in option number B, minus 1 raised to n into n factorial into 3 raised to n upon 3x minus 5 bracket raised to n plus 1. Okay, this is the correct answer. Okay, now similarly we can solve the multiple choice questions based on parametric functions and higher order derivatives. Okay, today we stop here. Thank you.